Hi everyone, my name is Dilyara. I'm a researcher at DeepPavlov, and today I'm going to tell you how to design multi-skill AI assistant using open source platform Dream. So our workshop will be about composing your own assistant using existing components of Dream platform. Currently I'm going to use Visual Studio Code Editor for our workshop today. And you can see here our main links. So the open source platform is available on GitHub. And also we have our own website with the description and links to our Medium posts and to the video where me and other people describe our Dream platform. And also we have a demo chat with our English Dream Social Bot version on the website. So feel free to use these links and let's start. Let's start from the README file. I already cloned the repository and I already have a Docker and Docker Compose installed on my machine. And so I'm already able to use the Dream either locally or via proxy. So I have an access to Docker. And I offer you to start from the Dream social bot picture. Let's look at it. And this is a full image of what components we have currently in our dialogue system Dream, which is like a full version of the dialogue system, which can be created using our current Dream platform. So the overall architecture is based on the DeepPavlov agent, which is also an open source framework for building high-load asynchronous pipelines. So you can find an information on our website too, DeepPavlov AI. And the overall architecture is the following. So we are getting the user input, which is some text. We proceeded with annotators, which are a lot of different natural language understanding models, like sentence segmentation. So this is a punctuation recovery, also entity recognition, entity detection, different classifications like sentiment, emotions, topics, and dialogue acts. Also, we also have spell check. We have a lot of different components for natural language understanding. And after that, the annotated user utterance currently with the dialogue state itself, it's a saved to dialogue state, and also we give all this information to the skill selector, which is a part of dialogue management in our Dream architecture. So the skill selector is simply selects a list of skills that will try to proceed to generate a response for the current context. So after this, all those skills, chosen skills, are called and they generate 1, 0, or several hypotheses each that are like response candidates for the current context. And after that, we need to choose the final response among those given response candidates. We annotate them with several natural language understanding models to make it easier for response selector to choose the final response. So for example, we are filtering bad utterances that contain some toxicities, etc. So after that, response selector gets all these annotated response candidates along with the dialogue context available, and using some different tricks and algorithm, it chooses the final response, which will be returned to the user. And after this, the response is given to the user, and by the way, is also processed with the post annotators, which simply give us some necessary information about what social bots utterance. So the pipeline is simple. We are annotating the utterance, we select skills, we call these skills, they can generate hypotheses. After that, we annotate them, those hypotheses, and we choose the final response. So everything is simple and quite straightforward. What is important? All those models work asynchronically. We have only two moments of synchronization that are skill selector. It waits until all the annotators will annotate the user utterance, and also response selector, which also waits all the skills and all the annotators to finish processing these response candidates. So we can see here a lot of different models, a lot of different skills, and for our current workshop, we are choosing just the most simple architecture that we can imagine. So let's say that we choose only sentence segmentation model, which recovers punctuation, so splits the sentence into the utterance into the sentences, and also determines what is the sentences. Either it is dot sentence or it is question. So let's also stay with this spelling preprocessing. Why not? It's okay. Okay, let's say these two, and also let's choose program-wide skills that are ML-based skills, and also let's choose dummy skill because this contains some fallback responses, and we simply like it. Okay. For the candidate annotators, let's choose only conversation evaluator because we need some scores to not randomly select the final response. So having these conversational evaluation scores, we will have an opportunity to more smarter choose the final response. And also we have this final response selector. So let's start from the creating the folder. And what folder I'm talking about, I could show you using our README. So the main information about it, that we use the distributions. So we have several distributions of our social bot. They are using the existing components that are presented in our platform now, and using this methodology, we can just simply understand that having these distributions, if we want to create our own social bot, our own dialogue system, our own multi-skill AI assistant, we need to create our own distribution. So for that, we need to create a folder, a configuration file. So as you can see here, for different Dream distributions, the difference is in these folders. So we try to make it as easy as possible. So the distributions are determined using this assistance, this folder, and we have several distributions in here. So everything is simple. The first file, so we can see this, any of these commands, we can see here that the first file is Docker Compose YAML that is stored in the root of our, let's see, what is it? It contains information only about agent and about Mongo, which is our database for the dialogue. So we have two containers that are simply common for all of the distributions. So this is the agent container and Mongo container. So agent is a container which exactly built from DeepPavlov agent. It synchronizes, so we can see here DeepPavlov agent. It synchronizes and sends all the information through all these containers, our microservices that we have in our pipeline. So this is the command for all the distributions, and then we have this assistance dist repository folder with several distributions. Let's say we want to create a new one using this Dream Dream, the full version of our social bot, which is available on the platform as a base, but make it smaller. So let's make it tiny. Open our terminal, and what do we see here? Let's let's copy. Have some assistant views. We have Dream, and let's make it Dream tiny. Why not? So let's see what do we have in here. Dream tiny. All the files that are available in Dream are available here. Let's say that we don't need some extra files. Let's remove them. We don't need these files, and these files, because we will not use, they are just simply used for more clever distribution of the information that is stored in YAML configs. But we do a simple version, so we don't need them. Let's start from the pipeline conf file. So we see here a lot of different information. You can see the size of this file, that's quite big, but this is what we do today. We are just making a simple version. So we have decided that we are storing only sentence segmentation and spelling preprocessing. So let's remove all other annotators that we have seen here. So this is just the same information that is mentioned several times in the file. This is an opportunity to make it once. So we're defining it here and just simply use it all over the file. So this is a last chance service that is used as a fallback when the pipeline breaks. So the pipeline broke itself, so it didn't return us any utterance, and then we use this last chance service. So there are two. No, there is only one fallback response, that something went wrong inside our social bot. So okay, let's leave it here. We don't have sentence rewrite, we don't have named entity recognition, we have only sentence segmentation. Let's also see what we have. Timeout service. Timeout service is a service when we have some particular time that the social bot can respond, that the multi-skill AI assistant, any dialogue system that is built using our platform, have some particular time, and if it's not fitting the time, the timeout service returns its own response. So I need to think more on that. So if the pipeline doesn't fit the maximum time, it returns this response. Okay, let's remove extra information. Let's proceed. Bot annotator selector. What should we annotate the bot responses with? So only sentence segmentation, we don't have anything else. So let's remove named entity recognition. So for the post annotators that are exactly post annotators are those annotations, we just leave in the sentence segmentation. For the annotators, this part, we decided sentence segmentation and spelling preprocessing. Let's remove everything else. So we just simply, so lots of annotators, and we remove all of them because we are making tiny version of our social bot. So let's remove it and see. Annotators, we have only two. Cool. Okay. The skill selector, we will left the current skill selector. It will choose not only the skills that are presented in the current version, it will choose naming. So I mean, list of skills will be much more, there will be many skills that are not presented in our pipeline, but it's okay. So they will be tried to call, there will not be these skills, and everything will be fine. So we just will not have these skills, but the skill selector will work. So we want to left program Y skill, IML skill. I don't know. We also letting dummy skill as a fallback. So pay attention here that this type of connector means that we are using this service as a microservice, as a separate Docker container. We are sending him requests using this address. And in this case, in case of dummy skill is a connector is connected with Python. So this is a part of agent container. The dummy skill is a part of agent container. It doesn't have any other separate containers for itself. So this is not a separate container. This is a part of agent. So let's consider everything else we will remove. I want one more skill, which is, why should I want it? No, let's stay only those skills. All those skills. So you can see here, only 2 skills. Okay. Post skill selector annotators. Post skill selector annotators. It sounds bad, but this is it. Let's choose the conversation evaluation annotator and nothing else. Why they call it like this? It doesn't matter how do we call it. Someone called it post skill selector annotators, but actually this naming is used only here because this is a part of the pipeline. It will be called in the particular order. So it doesn't matter how this is called. It's better to call it hypothesis annotators, I think, but it's okay. So this, the rest is like this. Let's see how many containers do we have. 1, 2, 3, 4. No, this is a binder connector. This is a part of agent. It's again 1, 2, 3, 4. And 5. So we have 5 containers that are not, and plus agent and Mongo. So, okay, let's start with the Docker Compose override file. Oh, so many information here. So we can see here that it should be tiny, Dream tiny distribution, and remove everything that is not about. Okay, it's okay. Nope, nope, nope. 1, 2, 3, 4. We have one more spelling preprocessing. That's all we have. And we do not have anything else. 5 containers. 1, 2, 3, 4, 5. Okay, cool. So see here. So remove this information. Remove this. Stay with this, and let's remove everything else except of program skill. No, this is a very strange to do it by hands, and I agree with you that this is not a very productive way. So let's calculate 1, 2, 3, 4, 5. That's all. Everything else could be deleted. So you can see a lot of different containers, and it seems to be very strange to simply copy and paste and do it by hand. Yes, so I agree with this information. This is really strange to do it by hands. So actually we are working on the automatic system. Dream, it will be called DeepPavlov Dream tools. That will be available also in open source, and it will give us an opportunity to make all these operations automatically. So you will just simply pass the names of the containers that you want to use in your system, and everything else will be done automatically. So we're ready with our Docker Compose YAML. We also have one more YAML config, which contains information about volumes and ports mapping. And let's also left here only the containers that we need. So moving. Here, oops, sorry, see here, Mongo. left it here. This is the database. So continue. This is how many do we have? 1, 2, 3, 4, 5, 6. Yes, that's all. Don't need anything else. So remove. We have 5 file containers and also Mongo. Let's see it like this. So finally, 1, 2, 3, 4, 5, 6, 7. Exactly as we have 5 containers and also agent and Mongo. Perfect. And now what should we do? What is this file? This is the file about database config. So we do not need to change anything in here. So we are almost ready. Check here, this is Dream Tiny. And here everything also is okay. And now let's see the README file. What do we have to do to build our social bot dialogue system? So here it is. So for any, we will be building it locally. So we see here this command. Everything's good. Let's open our terminal. So this command. Okay, but what should we remember? We need to change it to our tiny distribution of the social bot. Okay. So everything's cool. We are building this command. What it is doing? This is Docker compose command to raise all the Docker containers that are given in these YAML files, and we also have these containers to be built and to be upraised. So let's do this. So you can hear a lot of, as you can see here, a lot of using cache information. So because I have built these containers previously on this machine, so in your case, when you will open to build these containers, you probably will, it will take a bit more time than now, maybe a few minutes. Cool, cool, everything almost done. Yeah, so good. You can see here the different containers, logs. So you can see the main log of the dialog system building. This is everything's fine. The application can now start. So agent is built and everything's fine. So let's start. Let's try it. Let's open new terminal. This should not be closed because the Docker containers are upraised here. So let's open a new terminal and find the command to chat. So let's chat in here. So again, remember about the folder. So what is it? So let's start. Any idea that you want, anything else? Cool. And now your utterance. Hi. And we see here some additional developer logs, and it's optional. You can turn it off. So what can we find here? We have sent the utterance hi, and we have preprocessing, spelling preprocessing. We have sentence segmentation. We also have the rule-based skill selector, which chooses a lot more skills that are not available in our current distribution, but still everything works fine because our dummy skill is available and our DFF program Y skill is available. So, okay, what we can see here, the dummy skill returns several hypotheses. 2 of them, as we can see here. So the first one is the fallback, that I didn't understand what happened. And the second hypothesis is like a special link tool. This is a linking questions approach for our social board that you can read about in our technical reports. The links can be found in the README at the end of the README file or on our website. So this just a special questions with some preview information to continue to force the conversation in some particular way. So, and what else we can see here? This is the FF program Y skill that returns the hypothesis. Hi there, how are the things? And some additional information. So the final conversation evaluator annotator just returns the annotations for all three hypotheses that we have here, the first one, the second one, and the third one. So it annotates it with the several parameters, how the comprehensible, how erroneous, how interesting, how on topic, and how much it engages user. So then the conversation evaluation selector, response selector, just simply chooses that DFF program-wide skill response is the best. Let's choose it and let's return it to the user. So here is the bot's phrase. So, hi, this is a Dream social bot. How are the things? Great. How are you? So pay attention that, as you can see here, I don't like I don't have to use any punctuation because we have sentence segmentation annotator, and we can see here our response. This is split it into sentences, and we have several hypotheses from dummy skill to hypotheses, and actually we do not have hypothesis from program-wide skill, so this is empty hypothesis. It will be removed, and so the dummy skill linking question is chosen as the final, as the best response, because it's better than the fallback. So okay, it works. Finally, we did it. Everything is working, and you can use it. Just we did pay attention that we did it here for a very small distribution, very tiny distribution of our dialogue system. It contains only 2 skills. Both of them are template-based skills and do not cover all the contexts that are available. As you can see here, there is no special response to how are you. So choose in a smart way. Choose the skills, the components that you want to use. Thinking about who will provide the responses on most of the utterances that can be sent to this version of the multi-skill AI assistant by the user. Thank you very much.